Welcome to our fourth part of this series, Chapter Matter. We are making a full series on this chapter, Class 8 Matter. Where is the book? Here we have the book. Let me flip the chapter. We have Matter 260. So we are making full series on this chapter, if you don't know, by the way. And this is the fourth part of this series. And if you haven't watched the first one and the second part and the third part, the link is given. Tap the link, go ahead first, watch those part, and then come here and watch this part. And if you don't watch those part, then you will not understand this maybe. So first I recommend you to watch those. And today we are going to talk about subatomic particles. Subatomic focus over here. Subatomic particles. Can you tell me the name of the subatomic particles?
Electrons, protons.
Yeah, this electrons, protons, and neutrons. These are what? Subatomic particle. Electrons are which charge electrons have?
Negative.
Yeah, it is negatively charged particle. Protons, positively charged particles, and neutrons, chargeless. They don't have any charge, means zero charge. So in this video we are going to talk about these three things. These are called subatomic particles or fundamental particles, if you don't know them. And these three things helps to form an atom. This is the structure of an atom. This is how an atom looks like from inside. And this is basically atomic model, right? So before we begin and talk about these three things, let me ask you some questions from the topic that we learned yesterday, right? So can you tell me from this structure, which is nucleus?
The center.
Yeah, the center is what? Nucleus, right? The center is nucleus. And which one is electron? Electron. Yeah, these thing you see, these are electrons. And let me write here. Nucleus. Is that the correct spelling? No, that's correct. And this is electron. And where is the proton and neutron?
Proton is in the center.
The proton and neutrons are located in the center, not in the center. Yeah, you can say in the center, in nucleus, right? Protons. So that is, if in your exam it will ask you where protons and neutrons are located, then that protons and neutrons are located in the nucleus, because and this is neutrons. And shell, what is called shell?
Shell, the organ.
Yeah, this is shell or orbit, anything you can call it. Shell or orbit. Okay, so this is the structure of an atom. So you need to remember these basic things. So now let's start our topic, and we'll talk about like I already told you, electron, protons, and neutrons, subatomic particles. Let me erase this. Okay. First, let's start with electrons. So this is the short description of subatomic particles. Subatomic particles, means like I already told you, electrons, protons, and neutrons. So first, let's talk about the first subatomic particle, electron. Electron. The existence of an electron in an atom was shown by J.J. Thomson in 1897. So this is the name of the scientist who found electron right in an atom. So it is written that the existence of electrons in an atom was shown by J.J. Thomson in 1897. So I think maybe you can remember the name. I don't know if it'll ask the exam, but you should remember the name. Okay, in 1897. So this time scientist discovered what? Electron. The existence of electron in an atom was shown by J.J. Thomson in 1897. An electron is a negatively charged particle. An electron is a negatively charged particle. Electron, they are negatively charged particle. Electrons, they have what? Negative charge. Negative charge. Right? So remember this. Electrons, they are negatively charged. Its mass is only 1/1837th of the mass of a hydrogen atom. It means that if you have a hydrogen atom, and if you divide hydrogen atom in this part, I mean the 1/18th and 37th part of an hydrogen atom is the mass of one electron. So this part of only one little small hydrogen atom is the mass of what? Electron. Like if you divide the hydrogen atom in this part, then the part after dividing in this part, you'll get a single tiny very small bit of hydrogen atom, and that will be and the mass of that little hydrogen atom will be the mass of one electron, right? Like so this is very small, right? So the mass of electron is 1/1837th of the mass of a hydrogen atom. So if this is a hydrogen atom, and the mass of the mass of the electron is the mass of 1/1837th of hydrogen atom, right? So let's say there is some mass of a hydrogen atom, and if you divide hydrogen atom in this part, and then you will get a tiny bit of hydrogen, and that will be the mass of one electron, right? So it is written, you can understand by seeing this sentence. Its mass is only 1/1837th of the mass of a hydrogen atom, right? The mass of the electron is only 1/1837th of the mass of a hydrogen atom. So you can imagine it is even more smaller than what? An hydrogen atom, because it's very simple. Like electrons, they are in the atom, so it will be smaller than an atom, right? This is the mass. Let me light this over here clearly. Mass of an electron. Mass of an electron is 1/1837th of the mass of hydrogen atom. Okay, so the mass of an electron is 1/1837th mass of a hydrogen atom. So here its mass is only about 1/1837th of the mass of a hydrogen atom. Okay, so this is the mass. You have to remember this. Maybe it will get asked in your exam, so you have to choose this correct answer. Its mass is 1/1837th of the mass of a hydrogen atom. It is represented by E to the power minus. E minus and Y minus, this is charge they possess, right? Charge they have, right? So E for electron, and electrons, and they have what? Negative charge. They have negative charge. negative charge, right? They have negative charge. So its symbol is E minus. So also remember this. It always revolves around the nucleus of an atom in a fixed shell. So this is the shell. In the middle, it is nucleus, and electrons are on this shell, right? You already know, right? So they always revolve around the shell. They don't go anywhere from this. A. Yeah, they were going into. I'm just showing you that now. But if you make the structure of any atom, don't do that. No, I can't. Speaking in my language, okay. So these are electrons on the shell, right? So they always revolve around the nucleus in a fixed path. They don't like go anywhere from that path. They have their path, and they always work on that path, right? So this is a short description of electron. Now let's talk about proton, and then after that we'll talk about neutron. So let me erase this, and let me write here proton, and the description will come here. Okay, so this is proton, and you can see proton. The existence of proton in the atom. The existence of proton in the atoms was given by Goldstein, Goldstein, Goldstein. So this scientist, this is a scientist who discovered a proton. Okay, this is proton, and you can see this is the description of proton. And the existence of proton. Let me just see a little bit, please. It will be atom over here. The existence of proton in the atom was given by Goldstein, Goldstein. Goldstein. This is the name of the scientist who discovered proton. Goldstein. Okay, this is the name of the scientist who discovered proton. So the existence of proton in the atom was given by Goldstein, and he discovered proton in 1917, right? Okay, so this when it is discovered, it is not written in the book, but still I just wrote it over here. It was discovered in 1917. A proton is the particle that has a unit of positive electric charge. Means they have positive charge. Like electron, they have what? They are negatively charged particle, but proton, they are positively charged particle. Proton, they are positively charged. Means they have positive charge, and in electron they have negative charge. A proton is the particle that has a unit of positive electric charge. It has the mass equal to the mass of an atom of hydrogen. So the mass of hydrogen, mass of an atom of hydrogen is equal to the mass of the proton. Means the mass of the atom of hydrogen is equal to the mass of the proton. They are same. Let's say this is the one hydrogen atom, and this the mass. Its mass of hydrogen atom is equal to the mass of proton, right? So here you can see it has the mass equal to the mass of an atom of hydrogen. It has the mass equal to the mass of an atom of hydrogen. So one hydrogen atom and the mass of that mass of one hydrogen atom is equal to proton. Let me write here mass of an hydrogen atom is equal to mass of proton. So mass of hydrogen atom is equal to mass of proton. Also remember this. It is represented by P plus. P to the power plus. Why P? This is a symbol proton P, and they have positive charge. So it is that is why its power is what? Plus. I'm going to write here. Electron, it is A minus. Proton, it is P plus, and then neutron will come after this. Okay, so it is represented by P plus, and electron is represented by E minus, E to the power minus, and P to the power plus. It is located in the nucleus. This is the atomic model, and this is the nucleus, as you guys already know. Nucleus. So it is located inside the nucleus, right? Inside the nucleus, proton and neutron are located. So proton is inside the nucleus. Okay, and it was discovered in 1987 by a scientist named Goldstein. Goldstein. Now let's talk about proton. Neutron. Okay, so this is neutron. Neutron was discovered by James Chadwick in 1932. So this is the name of the scientist, James Chadwick, who discovered a neutron in which year? 1932. It is located in the nucleus of an atom. So as you guys already know, neutron, they are in the nucleus. They are located in the nucleus. Nucleus, right? So they are located in the nucleus of an atom. But the ordinary hydrogen atom does not contain any neutron. Like any ordinary hydrogen atom, they don't have any kind of neutron. Why they don't have any kind of neutron, I will not discuss in this video, because the video is already very long. We will talk about that in maybe later videos, in our future videos. So, but still, just remember this thing. The ordinary hydrogen atom does not contain any neutron. So any kind of hydrogen, the ordinary hydrogen atom, they don't have what? Neutron. They don't have neutron in their nucleus. It is an electrically neutral particle. Means neutral particles means they don't have any kind of charge. They are neutral, zero. They are zero. It is an electrically neutral particle, means they are chargeless, they are neutral, they are zero, whatever you call. They don't have any kind of charge. It is donated by n to the power 0. N to the power 0. Okay, let me write here. Electrons, they are denoted by e to the power minus. Protons, its symbol is P plus, and neutrons, its symbol is N0. N0 means they don't have any kind of charge, right? It is neutral. You see here, it is an electrically neutral particle. It is donated by n to the power 0. Its mass is about equal to the mass of one proton. Its mass is not totally equal, it is about equal. I mean, only a little bit equal. It is not fully equal, right? Its mass is about equal to the mass of one proton, right? It is not totally equal. It is only a little bit about equal, right? Let me just check one thing in the book, if I was written that correct. Yeah, its mass is about equal to the mass of one proton. It is not totally equal. It is only a little bit. You can see in the sentence, you will understand by reading the sentence. Its mass is about equal to the mass of one proton, right? All elements except hydrogen, they have neutron in the nucleus. I forgot, I haven't written that. All elements except hydrogen have neutron. This will be over here. Have, which A, we have neutrons. This is it. It is visible in the camera. That thing is neutron. Okay. All elements except hydrogen have neutrons, and hydrogen atom, they don't have neutron in the nucleus. We'll later talk about why hydrogens have not neutron in the nucleus. It helps to find the atomic weight of the elements. To calculate the atomic weight of any kind of elements, this neutron plays a very important role. So that was it for this video. The board is shining a little bit, but still you can see it. If you want, then you can take a screenshot, and that's it for this video. The next video will come very soon about this chapter matter. This is the fourth part. If you haven't watched the first, second and third part, link is given below. And that's it for this video. Make sure you hit that Z button, and I'll see you in the next video tomorrow.